Hey, welcome back to the stream. Sorry for the absence of stream last week. I was helping my parents move from Gatineau to Sherbrooke, which is about a 4-hour move. We filled in a big truck, and it was a lot of fun. Took 2 days. I retrieved a bunch of toys from the basement as well that were left, and I just sorted through them recently, so you can see that there's less stuff behind me today, though there's still this trusty huge pile of Lego boxes and models and assembled stuff. I did find one cool toy, though, that I wanted to show on stream, and it's this really cool 1981 Go Lion. So this is actually a Japanese Voltron. It's the precursor to Voltron, if you will, and most of it is actually die cast out of metal. And it has all these really cool transformation points. It's really solid and sturdy. It's I looked it up. It's a GB36. It's missing a few accessories and stuff, and the fists, which are normally you can actually fire the heads of these lions, these arm lions, are missing, unfortunately. I seem to recall having them when I was a kid. I think I actually bought this in a garage sale when we lived in Alberta, from the twins down the street, because I don't remember asking for this toy ever, or being given it. I'm not sure. But anyways, I thought maybe down the line I might try to actually 3D print some heads for this, so I can actually fire the projectiles again. It's a really nice model, and I don't want to get rid of it, even though it's worth a lot on eBay. It just has a really cool feel to it, and it brings back a lot of nostalgia. And even though, you know, the heads wouldn't be completely what's the word I'm looking for? Original mint. I'm not sure. Original, I guess. Then it would still be a lot of fun, I'm sure. Sorry, I'm getting a warning from OBS here saying that the streaming is buffering somehow. I hope that's coming through all right. I wonder what's going on here. Let me just really quickly see if I can figure out what's going on there. This doesn't look too bad. Oh, the virus scanner. I see. Yeah, I wonder. That shouldn't be affecting Twitch, though. Let me quickly check the stream health. Alright, so Twitch says everything is good, so I'm going to trust Twitch over OBS. Alright, so that's it for that. I wanted to quickly talk about the few things that I did do actually since the last time we were on stream. So last time I was on stream, I showed a bit how I wanted to iterate on this part here of the keyboard. Oh, not the keyboard, but the copper tape PCB. I've done so. I actually had a little feature here that I actually just suppressed recently. I think it was... Ooh. Nope, that was not it. Or was that it? Okay, no, sorry, never mind that. This feature I actually want to get rid of. There we go. It is this feature here. Yeah, it's getting slow to compute. You can see at the bottom right, it's taking a little while every time now because I've bought all these operations and stuff. All right, this feature here was a little registration gizmo, a little plastic nubbin that I was using to register inside the shell of the keyboard. Turns out that it's really not such a great idea after all. I tweaked it a little bit, and it really doesn't play that much of a role at all compared to all these registration tabs here and this part here, these cutouts here, these notches. These are really going to be what holds this thing in place. However, the screw hole here does seem like it could play a structural role. I iterated on this a couple times to get the placement just right. The one thing that kind of sucks now, though, is that here in Montreal, we're kind of hitting the summer is kind of just around the corner, and it's very, very humid around here. And so we leave the windows open all the time, and you probably guessed where I'm going with this next. I don't have a dry box for my filament, and the filament that I've been using for my prototypes is actually now starting to crackle and pop as I print. It absorbed a lot of water, which is really not good. So I'll have to figure out a way to dry it out. I have a good way of storing my filament, but when it's on the printer, I don't have a dry box with a little spool dispenser there. So I'll probably build one of those soon. It's a bit unfortunate because it takes more space. In the meantime, I mean, I can print these prototypes. It's workable. What I've done to kind of compensate a little bit is I just slowed down my prints. They're still kind of dimensionally accurate, or rather they are on sort of these wide, I don't know if the camera will focus on this, but on these bigger structural parts, they're fine. Where it kind of starts to break down is around the little screw hole. Oh, sorry. I've actually got a screw in there right now. It's a screw that will go into the keyboard. And part of the reason for that is because here I've got this big hole, right? The screw actually comes in the back of this hole here. And the screw head that I have is pretty big. It's actually a funny screw size. It's a number 5, so it's not a number 6, not a number 4. This is the screw size that seems to fit the original screw posts that were in the keyboard. So I'm not sure. You know, your mileage may vary, and I figure people are maybe going to try, well, if anybody tries this ever, whatever. But people are probably going to try this with different size screw heads, so I wanted to make sure the tolerance was or not the tolerance, but the available space for the screw head was sufficient. Now, what that means, though, is that as this gets printed from the underside, right, it gets printed this side down. Remember, we separated the PCB out, this piece here being the PCB. It means that when you look at this from inside, actually, you know what? I can show you what this looks like in Cura, which is the slicer, right? So this guy is figuring out how to make the slices on the printer. However, when you look at this from the underside, well, what just happened? Okay. That was scary. Actually, if I switch to the solid view, you can see this a little better. This is what it looks like, and Cura is actually going to color the underside of the model where it needs support. So this is the face that lays down on the print bed, so it doesn't really need any support. However, this part here is it has an overhang angle, which means the angle that, you know, with respect to the horizontal axis here, it's bigger than, in my case, I have it set to, I think, 55 degrees. So normally it would actually try to print support for this. Now I made one print with support, meaning that it'll print this like temporary structure here, this plastic zigzag that you're supposed to tear out. It worked-ish, but what I found was that I had to kind of force it out, you know, as it is with these holes here. I had to poke it out with a screwdriver, and I found that it didn't actually really help the end result. It didn't really appreciably change the quality of the hole, because when you break off the support, it leaves some janky bits anyways. So I actually just tried to print it without support, and it came out reasonably well as well. So I think, yeah, whoops, the screw came out. So I think what I'm going to do is just, you know, keep iterating on this without support. It's not perfect, but it'll be more than sufficient to hold this piece in place. PLA's, you know, it has a little give to it, and this part though is a little thick. It doesn't really give anymore, but it has just a little bow and flex. So, you know, if the print doesn't come out perfect, I think it'll still be okay. One thing that I did iterate on quite a bit was the angle of this surface, so that it would actually mate properly exactly with the tube. So you've got the tube, the screw post that's in there, and this part here, this face here, it mates perfectly, very close to the screw post inside the keyboard. But I do need to iterate on the placement of this hole a little bit, so I'm going to do that right now. And oh, I forgot, I suppressed this feature, but I don't want it anymore, so I'm just going to keep it around for now just for fun, but we'll see. And then I'm going to start a print, and then my plan is to switch over to the desk, my workbench, and to solder some connectors to the keyboard's motherboard. You may remember that from a couple episodes back, I had unsoldered the soft ribbon connectors for the original PCB, so there's no going back at this point. And I'm going to solder. I'm gonna take a rifle through my connector boxes and stuff, but I'm almost certain I'm gonna just use some regular headers. They're so easily available. They have the right spacing, and I think people are just gonna have a good time with them. The thing is that I just want to verify though that there's enough space for headers, normal headers inside the keyboard. I believe there is though, because you know the original connectors, if you look at the way they worked. First of all, they were pretty bulky themselves to begin with, and second of all, actually the original PCB was kind of folded up like this inside the keyboard, so there's a good depth there that the keyboard must have cleared. So the headers are going to be shallower than this for sure. So I'll I'll put the two clamps together, the clamshells, keyboard clamshells together to make sure everything gets cleared properly, but I think we should be good. I guess one of the main questions is, do I use females on the motherboard and males on the PCBs, or the opposite? We'll look at that. So first things first, I'm going to iterate on this, on the placement of this hole. So I'm going to say that it's really coming together though. I can't wait to print the first full piece like this. Now unfortunately I think for my final print I'm going to need to sort out, you know, dry my PLA or something there. But actually let me check something. Okay. I just wanted to check something with my my earlier prototypes there. Man, this is going to be so cool. I cannot wait for this project to be finished. Oh man, every day I use this crap keyboard. My wrists are telling me, please finish the Kinesis project. All right, so so what I'm double checking here is it seems like my original, I only printed a part, right? I didn't want to print the whole thing, but it seems like my original full-size prototype actually registers better inside the keyboard than this partial one, and I'm trying to figure out why that is. Maybe it might be that I think that's what my problem is. Okay, so first things first, I'm going to edit this sketch. I'm going to bring this in just a little bit. Oh, wait. If I do that, that's gonna mess up the screw hole. I'm tempted to just because the thing is that the screw hole, the way it's sketched, it uses the projection of this face. If I move the face, the hole is going to move. Which, like, actually, you know what? I'm going to combine two stones in one. So I actually need to move the hole back a little bit. And I need it to move in the opposite direction. So you know what? I'm going to arbitrarily move this down a couple millimeters. Or not a millimeter, but actually, you know what? How long is that? How long is... It's 10 millimeters. I'm hearing a weird echo. Oh, I see what's going on here. All right. Okay, blah, 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 make this parallel. What is this distance? 0.2 millimeters? That looks about right. So I'm just using this as a guide. There! That's about right. The thing is I don't have any measurements for this. It's really hard to measure. I just eyeballed it and that's gonna be good enough for me. All right, for now. And then this sketch here, whoops, no, it's this sketch here. I need to move the hole inwards and also outwards. Okay, so inwards by a bit. So I'm gonna move this down by an extra 2 millimeters. And I'm also gonna move it outwards, so a little bit out, a little bit further out by, I'm gonna say a full millimeter. So in order to do that, I need to take this extrusion and move it out like that. All right, this should be good. Okay. Now if I unsuppress this, got this part here. All right. Let's export that. See where this leads us. I wish Dropbox would fix this bug. This seems to be a Dropbox problem. The date, for some reason, doesn't seem to follow when you save a file. I say it's Dropbox because I only have this problem with files that are in my Dropbox, but yeah, I'm pretty sure that's it, really. All right. So I lowered the print speed a little bit so that things would turn out better. Let's see what kind of a time this gives me. Let me pull the SD card out. "28 minutes. All right, that's not so bad, really. Save to removable drive and eject. Let me just quickly start the print there. There we go. All right, off to the races. So I guess I'm going to continue on the workbench. All right. And I'm going to bring the camera down a little bit. Hopefully you can see what I'm doing there. I'm just going to bring up the focus control to make sure you guys don't miss out on any action. Configure video. There we go, so I can change the focus. Awesome. Okay. So let me move the keyboard. Let me maybe start by heating up my my iron there. Some water on my sponge. Woo! That was intense. Pull out my solder, these two spools, and I think that's about it for now. So for those of you who saw me desolder from the motherboard, hopefully this is a faster job. Bring the motherboard back. Alright, here we are. It's back. So my goal, actually I'm gonna have to turn this upside down. Like this, probably. So my goal, there used to be connectors here and here. Now I've managed to clean this up reasonably well. Oh, something got stuck to the board.
Dear Lord, I just lifted a trace. No! Oh, one of the pads got lifted. Okay. I'm like pulling on this like it's a piece of hair, but it's a trace. Okay, okay, this is not awesome because one of the vias actually... Oh, this is the first... Is this the first one that I pulled out? Yeah, this is the first one that I pulled out. I wasn't assertive enough. Okay, so the via is gone anyways. That's why the trace got loose. So the via is a little piece of metal that actually goes through the board, through which the pin is soldered normally. So I'm gonna have to repair this. This is not so bad. I'm going to probably, first thing, I'm gonna maybe glue this trace in place again, make sure it doesn't get... Ooh. Okay, actually, can I see where it leads? Let me quickly see if I can... Okay, it's really long. It's not the one on the edge. Is it the one on the edge? No. Damn it. At least to one of these pins, maybe. Okay, well, at the very least, I can solder to it, but this kind of sucks. This kind of sucks. Let me see. Alright, so what I'm going to do here is try to figure out where the other end of this trace leads. Now, hopefully this is a problem people trying to replicate these results won't have. Okay, let me just use a... Oops. Some more crap. Alright. So, try not to pull on this trace any harder, but I do need to clamp something down on it. Okay, wait. Okay, this is not going how I want it to. Okay. Okay. I'm gonna first clamp my clamp. Make sure it doesn't go anywhere. Then I'm gonna clamp to this trace, which hopefully won't put too much stress on it. So, okay, oh, I don't have contact. And I just broke apart a little bit of the trace. All right, that's not what I was going for. Though that piece was covered in solder mask, so it wasn't really useful to me anyways. Actually, before I even get into this, like, what is this? Okay, wait. Yeah, this is... I think even the part that looks coppery is not actually conductive. There's... Okay, maybe not. Maybe I'm wrong. Okay, so coppery, does it go to any of these pins? I don't think it does. I think it probably goes to the processor directly. So oh. Okay, so 5th pin down. All right, I'm feeling more confident about this. So at worst, we could run a jumper wire from the underside to where this trace used to sit. I'm not too worried about the header pins actually not being soldered to this via. Yeah, there's 1, 2, 3, 4, 5 other ones to hold it in place, so that's actually not too bad. Whew, okay. So if you're desoldering this connector at home, please be careful. I said what, 5th pin down, so 5th. Okay, so that is actually going to a, there's a perfect spot for a jumper. Perfect. Okay. It's really a simple PCB. Most components are through mount. Actually, all of them are through mount, so this makes it really easy to work on for a hobbyist. You know, I know it wasn't intended that way. I don't know if this was actually put together by a human or part of it was or not. I mean, it looks very consistent. But maybe it was picked in place by a human or something. So there you go. All right. So, okay, let me just take that down. You know what? I'll remember. Okay. In any case, I need to solder the header first. So let's figure out whether that's going to fit in the keyboard or not. Let me pull out some headers there. Do I have any shorter headers that I could use? I do. I have a couple in here. What did I use headers for recently? I soldered them to, oh yeah, an Arduino Nano, that's right. Sorry, Pro Mini. Really, one of the really small ones there, didn't have any. All right, you know what, I'm just gonna flip this out there. There we go. All right. Okay. So that's about the form factor of it. That's what this would look like. Look like that. And there would be a second row right here, right beside it. They're slightly offset by what appears to be a 1/20th of an inch instead of a 1/10. I need to sand this one down. But yeah, I'm almost certain this is going to be fine. So these keys are actually, this is on the underside, so I don't need to worry so much about this part. Let me see. Let me remove this from the way. All right. Let me temporarily put this back in here. Temporarily. Man, if anybody from Kinesis is watching right now, I apologize for the way I'm, quotes, manhandling your hardware. I love this piece of equipment. It's really one of my favorite possessions. All right. So yeah, you can see. I'm pretty sure there's enough space in there to for that connector to sit. And even if I was to there's a lot of space in the shell here. A lot of space. Because the way it works is it kind of curves up here. You see it kind of curves up and actually creates this big volume here. That really gives me a lot of room to play with. Let me just check with a flashlight to be like triple positive, but yeah, there's oodles of room in there. All right. Let me take a really quick bathroom break. Sorry about that, and I will be right back. All right, I'm back. Sorry about that. All right, so we're saying, going to solder this onto here, and I'm going to run a jumper for the pin with the broken via. All the other vias look good. So my question was, do I use a female on this side or a male on this side? So how many pins do I actually need there? Not all the pins were used on the original ribbon PCBs. So one of them is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yes. And this one has 1, 2, 3, 4, 7, 11. Okay, so 10 or 11. I'm planning on probably using rainbow cable, which is this like, well, in my case, it's pre-terminated cable. I have some that has male ends and female ends. I like the look of the way this behaves. It looks, it's very convenient. And you know what? I'm actually going to look right now. I actually think I have more that is that true? Female, 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 female. So maybe I'll put some males on the motherboard, you know? Yeah, and I've got a bunch of spare females here, so maybe I'll put some males on the motherboard. Alright. So the males are a little easier to work with because you can just cut off the parts you don't want, whereas with the females... Actually, you know what? That's a good point. So with the females here, what happens is if you don't drop them and chuck them all over the floor... really? Okay. Is when you want to get only part of this, what you have to do is you have to cut in the middle of one of the pins. You actually lose one of the pins, and then well, that's not really a bother because I have a lot of these hanging around. But the problem is you have to kind of sand the edges afterwards. It's not really a nice process, and it always kind of stays rough, and it doesn't really have this nice sort of finish to it. Now, by using the female rainbow cables, I can get that nice. You know, the female end is going to be very nice, and the male headers here are going to look kind of nice as well because you can just cut them off with some cutters. So I do have some gold-plated male headers here. A couple gold-plated left. I don't really think that gold plate is going to make a difference in this case, but it's going to look better. And you know what? For the price, the value of this keyboard, I think it's worth it. So I'm going to start by preparing my strips. So 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6. Let me get my cutters. I said, let me get my cutters. Hello, cutters. Are they on my desktop? Oh, no, there you go. There you go. So, sorry, that took longer because I've actually been watching a lot of, I've been thinking about ways to better organize my tools and my stuff, and I've been watching a lot of Adam Savage's videos about first order retrievability and his own workshop, the way that's organized and stuff, and it's super interesting stuff. And even just looking at the tools that I use, right now I'm still in the sort of drawer phase, and he calls his phase F drawers. Because that's what he says, that's where tools go to die, and I kind of agree with him to a certain extent. I mean, it's very inconvenient for me to have to reach in there every time, but I mean, mostly it actually, because I don't want to put it back in there, I tend to just leave it on my desk when I'm done with it, and that consumes this prime horizontal space that's supposed to be reserved for making. So actually, let me go back to doing what I do best, which is, well, not really what I do best, but getting stuff done at least. So 1, 2, 3, 4, 5, 6. I said 6, right? Yes, 6. All right. So you just cut it right in between the pins, and comes right apart. 1, 2, 3, 4, 5, 6. So let me get the other 6 out of the way. 1, 2, 3, 4, 5, 6. Like this. And I hold them so that they don't go flying. And then next will be 7 and 7. So 1, 2, 3, 4, 5, 6, 7. 2, 4, 5, 6, 7. All right. And then 1, 2, 3, 4, 5, 6, 7. All right. I'll put the cutters back in there. Put these pins back in here. These header pins. Put the females back elsewhere. All right. Now I'm going to take the motherboard back out of the shell. Keyboard shell. All right. And I'm going to turn it upside down again. So this hopefully will be a lot easier than soldering stuff the first time around. What I'm gonna do is I'm gonna use a trick. I can't remember where I saw this really. It's something that comes up in a few online videos, but basically what you do is you tack. So you use for the first pin, just tack it in place, and it just has to be approximate, right? And then what you do is you push down on the pins themselves, and then you just remelt that tack so that you can really seat it properly. I don't really need this glove actually. It's gonna hinder my ability to feel what I'm doing. So first things first, let's turn on the iron. All right. So this is my iron. I'm actually using a really fine tip this time. Last time I was using a really coarse tip to do the desoldering. So I'm gonna get the iron heated up. Almost there. There we go. And we're at temperature. All right. Okay. So I'm just going to fit this in here in the right place. Like that. Oops. And I dropped it. May not even need holding in place because it's pretty tight. All right, so I'm gonna clean my tip, take a bit of solder, just tack it in place, you know what, and a little bit more solder. So this is gonna create a cold joint, what I'm doing right now, which is no good. But I just want enough solder to hold it in place. All right. Then I can solder the other ones. And then I'll reflow the first joint. And then I'll be good. I'll be off to the races. Got a bit too much solder on it. I don't like the look of it. I'm going to clean that up just a little bit. All right, and then just resolder on it. a little bit. There we go. So that's the first strip of headers done. This is going much faster than the desoldering job. The print is at about 68%. And it's not looking half bad. Yeah, the lowered speed really helps with the fact that the filament was kind of all wet there. Part of it, I'm not sure exactly, you know, the filament is tightly wound on the spool as well. So I'm not sure that the inside of the filament, like the one that's inside, it gets exposed to as much water. And I've been using quite a bit of filament early this evening, so it's possible that I kind of went through the bit that's just kind of hanging out in the air, that's most exposed to the moisture. I'm really not sure. So let me solder my second row of pins. Let me check the underside. Is that good? Yeah, that is perfectly aligned. Awesome. So, there we go. You know, this fits nice and snug. I don't even really think I need to hold it or tack it. I'm just gonna go for gold and try to solder it directly. That's what I'm gonna do. And we'll see. I'll do the furthest one first, just in case I do need to replace it. It's gonna be easier for me to do that. All right. This looks perfect. All right. So I'll do the next ones. Alright, this looks pretty good. Bring in the camera to see if I can't show you a little better there. Try to see if I can't pull in the focus a little. That, and then be like this. There we go. Doesn't look too bad. It actually looks a lot worse on the camera than it does in real life. There we go. It's not too bad. It's going to be functional, I think. If you look at the underside, it's really not so bad. It's going to look clean, so I'm going to go on and do the other side as well. Alright. Just going to proceed the same way. Alrighty. Okay, so this is the one with the is it? Wait. Okay, sorry, it's on the other side of the I'm gonna need to jump the pin. Okay. 1, 2, 3, 4, 5, 6. You know what? I can actually go and fit both of these in at one time, I think. And maybe solder them both. Just in one big go. Because they fit in so nice. I think the reason for this is because the original connectors had these really, really fine pins that I believe were circular. Yeah, they were circular and very fine. The pitch was smaller than these square pins here from the headers, and the headers kind of rub up against the edges of the vias, and it fits really nicely. Yeah, it just kind of holds them in place. All right. So round number 2. All right. In the iron there. Alright, so here goes nothing. The table's shaking a little bit because the printer is doing all those aggressive movements, 93%. So let me double check the alignment. That looks good. All right. So you can see I'm kind of bending over right now. This is not super comfortable. It's not something I normally like to do very much. This is a standing desk. It's at maximum height right now. When I'm eventually, oh, you know what? Let me do one thing at a time. Let me finish what I'm doing here. Okay. This printer's being obnoxious, 97%. It's just zigzagging back and forth. Shaking my surface. And 4 to go. It's a really nice board to work with. It's, you know, it's very forgiving. I think even that, oh, I'm missing a little bit here. There we go. You know, aside from that, actually the desoldering job is a bit of a pain, I must admit, on the big connector, but the soldering job is sort of famous last words, but it's more of a traditional, sort of not too complex job that, you know, even as a beginner, I don't think it would present an incredible challenge. But getting the old connectors off was a bit more of a pain, I'll admit. So how did this come out? Oh, actually it came out pretty well. Yuck. Oh man, that filament is really in a poor state though. See, the thing is that the fine details, yeah, I'm starting to get ridges and the fine details are coming out really bumpy, and it's a bit of a shame, really. Yeah, it's not too bad, really, you know? The hole came out nice. Whole thing came out okay. See, these little ridges here, though, they came out really poorly. You won't be able to see this on the webcam, but there's some really fine crap in there. Anyways, maybe I can, I don't know, well, see what I'll do for the final roll. I can try to dry this. I can store it better. I can switch filaments. Number of things I can do. So I don't think I'll need the soldering iron anymore for now. Let me just prepare it for storage. There we go. Turn that off. And then let's turn this around and see what it looks like. This doesn't look too bad. In fact, if I didn't know so, I'd say this almost looks factory made. Check it out. Well, you know what? Let me move the camera instead. It's going to be less hazardous for the motherboard. So you can see these connectors here and there. They don't look too bad. Okay, but now I do have to, oh sorry, yeah, you know what? Let me turn the iron back on. I'm going to have to run that jumper wire. Okay, so that was this trace, and we said it's the 5th pin down. And the 5th pin down, turns out that it's actually, okay, wait, let me just double check there. Some people think I like to double check everything too often. I've been accused of this, and it's, I stand by it. I'd rather measure things twice and cut them once than the opposite and get it wrong. So we said the 5th pin down, right? Beep. All right, so it turns out that the 5th pin on the underside here actually goes to a via right there. Now this via is going to provide for a great point for me to solder my jumper wire to. And what I want to make sure though is if I look at this again, I want to make sure that it's the right pin I'm connecting to. I'm almost certain. Let me take off my glasses there for a minute. Yeah. Yeah. Yeah, okay. So it is the uppermost pin on the inside track. So I'm going to cut myself a little jumper wire for this. Oh. There's a screw that's trying to escape. I think it's the screw for this cable here. You know what? I'm not 100% sure which side this was on. Or where it was screwed, to be honest. I have pictures of this though. I'm going to keep this screw around. The same with the other ones. Nope, it's a little shorter. It's a little shorter than the other ones. So I'm going to leave this in here for now to be sure. Yeah, and then we'll figure this out later on. That's not too worrying. All right, so jumper wire. So some people like to use solid core wire for jumpers. Personally, I'm a fan of stranded, but very fine. So pull out some 24 gauge stranded wire. And then pull out the wire stripper. It's gonna need to go, so we said topmost from the inside track from here to there. So don't make it too long either. So something like this maybe. Alright, won't need this anymore. And I don't like, for jumper wires, I really don't like there to be too much wire that sticks out that's not insulated, because it's very close to the PCB, and if there's anything that touches anything it shouldn't be, you know, it might actually short circuit. So this will be good like that, and then like this, like so. I should be careful. Are there standoffs? There are standoffs. Wait. So I think there's only one screw though for this. Yeah, okay, and the standoffs are on the edge. Yeah, okay. Because I just want to make sure the wire doesn't interfere with there we go. With the positioning of the motherboard inside the shell. So I put this tool back where it goes. Same with this. All right. No. Now for this though, I might want to use a second hand, or a third hand, I should say. Or a, what is this, ninth hand, I guess, since there are 7 articulated arms on this thing. Okay. Okay, and there we go, like this, like this. And then like that. All right. So All right, that's one end of it done. Okay, and then we said it was this pin. So for this pin, I'm actually going to shorten it just a little bit. So I really don't want it shorting with the neighbors. I'll try to go at this from the side. Pivot the motherboard around just a little bit, like this, maybe. And then, okay. Okay, let me try to. It's really hard to get these things aligned, but you really do want to spend the extra time making sure it's aligned just right before you start soldering, because the last thing you want is this to start moving while you're working. You've got the molten solder all over, and anyways. Okay, looks good. All right, now I can turn off the iron. I suppose I could glue this to the board, or for now I'll just tape it, you know. I actually have some really nice electrical tape. I was at the Home Depot for my birthday, and I was just looking, and I was like, I should buy myself something, you know. And I went, you know what, I'm almost out of tape. And I went and I looked, and there was all these bins on the bottom of like cheap electrical tape, you know. And then there was this one tape on the top, the Super 33 Plus, for people who know what it is. And of course it's like, you know, twice or three times as expensive as all the rest. I'm like, I wonder if this is really worth it, you know. And I look it up online in the forums, and people are like, you gotta buy it, it's the best. And the you know, critics are raving and so on. I bought it, and I do not regret my purchase. Holy Christ. I mean, I still use the cheap stuff once in a while for things that really don't matter, but you know, once you've gone to the 33, it's hard to go back, I gotta admit. I'm just gonna tape this nicely. And so one of the things that people like about this tape is that, first of all, the adhesive doesn't remain sticky, so you can stick it, unstick it, no problem. That's great. The other thing is, you can see it's actually really nicely mapping the detail here, because it's very thin. It's very thin, and it has this stretch to it that actually kind of retracts over a number of seconds, where N is like 5 or something like that. So you stretch it a little bit, you glue it, you set it, and then it kind of retracts and really wraps those features nicely. So here I'm pretty confident this cable is not going to move. I mean, it sucks that I had to do a repair job to begin with, but whatever, it'll work. All right, so this motherboard is ready for some connection to some switches and stuff. That's good, that's good. Let's go back and see how that print turned out. All right, this is an old one. Let me move the keyboard motherboard back to its temporary resting place. All right. So How did this turn out? Oh, oh man, this turned out perfect. The whole, so you saw the number of like 0.5 more, and I just dragged that line, and it looks perfectly aligned. And I do mean perfectly, like it looks spot on. Let me fish out that extra screw that I had earlier. And the registration looks great. And this one, it's not moving at all. I think this is the ticket. I think this is the ticket. So let me just use a screwdriver. I believe it's the green, or is it the yellow maybe? I'm not sure. Green. Oh. So it's not coming out. But it's not bottoming out either. Ooh. Not sure. It's kind of a weird feel to it. It feels like it's barely in there, but kind of a weird feeling. Is this a print that's doing this, or is it, did I eat through the plastic? Oh, I'm still missing one thing, which is these prongs from the back of the PCB to stick on the top side of the keyboard shell. Okay, so I could model that right now, get a print started with that. Yeah, let's do that. Let's do that. And then once that's done, I think it's time for final assembly. I think. All right, let's go back to the main desk. You know what? Let me get a really quick glass of water because it's blistering hot in here. All right. I might try to get some slightly longer screws, actually. Maybe the ones I have right now are a little too short. Well, nah, that can't be it. All right. So,
let's model this. All right, so this is going to be on the underside, quotes underside, which is the actual underside, and I'm going to model this before we split the body, which is here. All right. I could group all this, clean it up. I suppose I could. All right, so regroup. Name. Mirroring, and then I will. And this is just the start part, so. All right. Wait. See? I screwed something up in there. See, this is the part where I think I need to explode the group. Delete group and expand its contents, and then I need to recreate the group. So this is to split, and then this is to mirror. Okay. All right. Okay. Sorry. Yeah, this is all like registration. All right. I could create another group. It's fine. I'm not too bothered by this. I mean, I've gotten histories before that are like monitor widths wide, and that's pretty terrible. But in this case, it's manageable. Sometimes I name the sketches as well when it gets really complicated, but in this case, it's not so bad. To kind of just click, because you can click on the feature and it tells you what it's related to on the timeline. So sometimes it's not like this face came about from, well, yeah, 2 operations, I guess. But yeah, it's a pretty easy way to navigate, right? You can see this is from here, from this group, this edge, and if you click on it again, it'll show you, okay, it's this feature. So they've gotten better at this over time. It used to be that when you click on something, it wouldn't always tell you what it was from, but they're so active, they make so many fixes that, oh wow, we could restart this and get a new version. All right, not now. So we said pins on the underside, or some kind of a registration feature. Actually, so I have to be careful here with what I do, because let me see what this looks like at the very end. Man. See, like now, there's this problem because this set of lines here doesn't make it all the way to the end. So one of the regions was lost. There we go. And then this extrusion and this one as well. See, edit sketch. Sorry, I'm not finishing those sentences, but what I'm trying to say is that part of the, whoops. Part of the isolation routing, the gouges didn't work. But now everything should be fine. So I'll double check all this before I, solder the final switches and everything. But it should be good. In fact, what I'm going to do is I'm going to print this. I'm going to do the CTPCB and everything. And then I'm going to probably... That's it. I'm going to connect the wires to the motherboard temporarily, as they would be if they were soldered to the PCB, and I'm just going to touch wires across these sections here to pretend as though the switches were closed, and I'll make sure that every single key, that function keys and everything, work properly. Once I know that worked properly and all the logic is good, I'm just going to solder everything in place. It should be good to go. Be nice. And then I'll do that all over again. The whole connector ripping out and everything for the second keyboard too. But at least the one that I'm taking apart right now is the one that was in worse shape by far. The other one that I have on at work is terrible, but it's still somewhat workable. I've got a couple function keys I can still use, and I've remapped back and forth. So I'm sort of living with that for the time being. And ironically, two of the MX Browns are starting to kind of get flaky on that one, so we'll see. Maybe I have to replace those as well. Those are very much a lot easier to replace though. Okay, so yeah, okay. My goal was to figure out where can I stick the prongs. I think the prongs would probably be best along this bottom band here, because this is the part. Could I stick some very close to the top too, maybe? See, the thing that sucks is that this is going to make it more difficult for me to lay the tape down on this surface. Let me see what the keyboard shell looks like on the inside. These prongs, each one I'm going to have to kind of iterate on the length because the keyboard shell is uneven, so it's just going to be empirically, printing, testing, printing, testing. So, what do I do? Unless I could somehow make these prongs another part. Then I could just do the PCB and stick it on top, have it register somehow. That would make assembling the PCB easier. Sorry, I'm just looking for inspiration here. Okay, well, okay, I think I know what I'll do. The first thing I can do at least is figure out the length and the positioning of these prongs. And then I can figure out whether I put them as part of the same piece or whether I print them apart or something like that. Well, I suppose if I put them on the very outside here, well, I can't cut too much into into this. What's the distance here? Oh, 2 millimeters? 2.6 millimeters. So I could take up to like, yeah. Because if I take off a band here to make these prongs, I keep saying prongs, but maybe this is not a prong. Maybe this is like a big extrusion, full length. Full length. That would make it really hard to cut into the tape though. Okay, maybe prongs are better. So, and here, this would work too, right? This idea. And what's the distance here? I know I was eyeballing a lot of these. Whoops. Distance 2 millimeters. Ideally, I want some on both sides, actually. Let me check again the keyboard shell. There's a taper on a bunch of angles and stuff. It's kind of complicated. Okay. What I'm going to try... Will this work? I think it could. I mean, who bangs on these keys anyways, right? Okay, what would be awesome is have something huge here, because we don't care, no PCB there. Maybe extrude this a little bit, like I've got maybe 3 millimeters. And I could go and push it out past the edge. Have a big ass, big extrusion here. And then maybe something in the middle. But let me just pick out one of those test prints. I don't know, man. This is pretty. It's pretty sturdy. I mean, it doesn't have a lot of give. It does have a little bit of give, but nobody's gonna bang on these keys anyways. I'm gonna try it without any prongs in the middle. That's what I'm gonna do. And if I do need prongs, well, I'll add one. All right. So, okay, let's go back here before the split. And then let us extrude on this end by an extra 3 millimeters. And then on the underside, D240, all right. On the underside, I need to project this, and then I'm going to put 3 millimeters. That's the size of that extrusion. Stop the sketch. Extrude this down by, who knows? I'm going to need to draft this by another who knows. So I need to modify, draft, lol, faces. Say 15 degrees. That looks about right. I'm just making this up, and I'm trying to measure it more accurately before I actually print something. And then I could have another one of, oh, you know what? I could actually, the same sketch here. And then edit this one as well. And then plane. There we go. So wait, that undrafted. Plane selected, angle 15 degrees. Plane faces. Wait, what? Nope, definitely not. Wait, plane, this plane, no, sorry. This plane, and then faces this, and oh, I see, I can't do more than one. Okay, it's possible that I might not be able to. So I actually think that I can't do this one at the same time either. Because in the keyboard, there we go. In the keyboard, what happens is the depth is not uniform here. The case is not, it has a varying depth. So I'm going to try to go and like this, another 15 degrees. I'm not sure what this is going to do. It's probably not 15 either. Okay. So that way we can take the tape, run it all the way down to the end. And you know what I'm going to do? I'm actually going to edit the sketch a little bit. I'm going to change this to say 2.5. And then what's this dimension? D242. There we go. Make it a little less. Okay. Now, that's the way this is going to sit inside the keyboard. Just want to make sure my drafts are in the right direction and everything. And I'm trying to get some measure of how long these things should actually be. Okay, snap the shells together. And then I'm gonna try to just feel my way in there. Oh, it feels nice, I gotta tell you that much. And there my printed part goes. So first things first, the draft here has to be, ooh, let me see, has to actually angle. You know what, there may not actually be a draft, or if there is one, it's going to be very slight, but it does need to angle back though. That's something I hadn't really realized. So let me get rid of this and get rid of that. But then I need to make both of these draft. Okay, so plane, faces, and then this one. Can I do that? No, I cannot. Damn it. Okay. Can I do this and then this and then this guy? I cannot. All right. See, I don't want it to stick out like this. What I want... You know, what I could do is actually just make a sketch on this axis. You know what, why not? Why don't I make this sketch just grossly larger, like that, and then like this, like that. Stop that sketch, extrude. This time I can combine both. Add the feature, extrude this, 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 and this for 40 millimeters, because I'm rich in millimeters. All right, like that. And then I'm gonna create a sketch here. And I'm gonna try to project this. And then I'm gonna go like, okay, wait. Yeah, it has to angle back like that. Who knows what it actually is. And then cut this off here. Parallel. Make a distance constraint, say 5 millimeters. That sounds about good. Then I'm going to extrude this guy out this way, say intersect. Ooh, no. I know this is a really weird way to model it, but I wanted the right depth. And instead of dealing with, the thing is that you can also do extrusions from offset planes. So I could offset these planes and extrude from here to here and there to there. But I'd rather not have to deal with these dimensions. I feel that it's kind of unwieldy the way it works right now, because you always have to bring up the dialog to be able to offset your extrusion planes properly. And sometimes if you actually extrude from profile, that I've had sort of mitigated luck with that as well. With this, at least, I know I'm going to get the result I want. So, you know, your mileage may vary. I'm going to actually create a large rectangle here, like this. Stop the sketch. There we go. I'm going to extrude this. Cut. Bring back the sketch. Re-extrude just this part. Cut. Bang. There we go. So, look, it's not, you know, it's not a very usual way of working. I'll admit that. But this gives me precise constraints, like precise control over the angles of all these things here. Rather than using drafting operations, I can actually sketch the profile that I want. And also I don't have to, by using these sort of like dual extrusions, I'm using a bit more CSG, which is expensive, constructive solid geometry, you know, some intersections and all that stuff. But I'm not having to deal with extrusion offset planes and so on. When I say extrusion offset planes, I'm talking about this here. Start from profile plane, offset planes, or from object. Had mitigated luck with that. So, and it's kind of unwieldy as well, because it's not a visual thing. You kind of have to punch in some numbers sometimes. Whereas with this, there's no question about what's going on and what's happening. So if I bring this all the way back to the end, will it work? Will it solve? It does solve. All right. Very nice. Splits properly and everything. So what I think I might do is print this piece. Now, is it even remotely right? It is not. See, it should be the opposite. This leg should be shorter, and this one should be longer. So I'm gonna fix that right now. Say remove this from the profile, and then uh-oh. Did I just crash it? Oh, don't tell me I crashed it. Oh, don't tell me I crashed it. No, it's never hung in me before. No. Oh no, dear Lord. Uh-oh. I don't like the look of this. Oh! How about a save? All right. And now for this one, I cut into this. Is it going to do the same thing? No, okay. Wait. Oh wait, it failed to solve this operation? That's weird. Wait, what? For this guy. Okay. Wait, what am I? There we go. Oh, okay. Sorry. I do. Okay, sorry. I do actually have to use an offset here, but it's not an important offset. You'll see what I mean. So offset plane, I just need to set it to, like, I don't know, 30, so that it, oops, minus 30 then, whatever. So that it starts further out from this leg. That's all I need to do. But this distance is not precise. It doesn't have to be precise. I just need to, there we go. There we go. Now the inner leg is longer. Now, does this actually make sense? This length here is what? 18 millimeters? Okay. And this is 13 millimeters. Sure. Is that just even the right ballpark? So like 13 millimeters, is that right? Or 18? It's not so bad, but my gut feeling is it's going to be closer to 20. And 20 and 16. And this is really eyeballing it there. So that's about the look of it. I mean, this is starting to look like a spaceship. Wow. Okay, if I unsuppress this. Oh, you know what? I cannot suppress this because I need to print the whole thing. What I could suppress for fun, though, is the PCB. But you know what? I want to see what it's going to feel like structurally with all those grooves in there. So, alright, let's save again. I had renamed these earlier, it's just that I did so many operations that the original bodies were lost and it kind of lost track of the original names. So PCB traces right. It's starting to be a pretty sizable piece, eh? No support needed, really. An hour. Wow. Oh man, with my crappy filament, these moves are going to be really, really poor. I'm just playing around with speeds here to see what kind of a difference you can get on print time. 42 minutes, yeah, this is not... Okay, so what if I set it to 40 millimeters a second again? In an attempt to get it to come out right. So the back of the keyboard is flat. Back of the keyboard shell, I should say. It is nice and flat. Almost. Almost. It is pretty much flat for the reason, the part that it interests us. All right. So I am going to set up this print and then probably call it an evening, since I'm not, I mean, I'm going to need to crank out a couple prints before I can make any more meaningful progress on this project, I think. Just tweak those sizes and those prongs, and then just double check the PCB circuits, which I don't really need to do on air. And then assemble everything, hopefully. Unfortunately, that won't be this weekend. I am out. Probably next week. Alright, start the print.
the print is started. So, yeah, like I said, I think I'm going to call this a night. It was a good progress. I'm happy with the connectors on the motherboard. I've got a good plan with the rainbow cable to use the female-ended connectors to connect to the motherboard. And I should be able to hopefully dial in the design for the everything that has to do with registration for these printed parts. Double check the PCB and hopefully assemble everything next time. It's really starting to get close to the end. All right, so
thank you for your time this evening, or anytime actually if you're watching on video on demand. I hope you're enjoying this. I sure am eager to get to the end of this project so I can enjoy these keyboards. Once again, I mean, you know, they were great in the past. They'll be even better now. So yeah, cheers, and hopefully see you soon. Take it easy. Have a good one.